Assalamualaikum warahmatullahi wabarakatuh. I'm Mawarni binti Ismail from Polytechnic Muka would like to present about characterization of flexural properties of glass fiber, pineapple leaf fiber, PALF hybrid composite. Here are the other authors in this study. Marlina binti Muhammad from Polytechnic Muka, Liana binti Yunus from Polytechnic Muka, and Muhammad Hazim from First City University. First of all, why we choose this study? This is due to the world environment pollution become worsen day by day, encourage researchers to develop materials based on natural fiber. And why natural fiber? Natural fiber is a biodegradable material, renewable, non-abrasive to the equipment, less health risk, low cost, and low density. But mechanical properties of natural fiber are unable to compare with synthetic fiber. That's why we come up with hybrid composite. So what is hybrid composite? Hybrid composite is a combination of two or more material purpose to reduce dependency to synthetic fiber. Hybrid composite can be natural fiber plus natural fiber, synthetic fiber plus synthetic fiber. But in this case, we choose natural fiber plus with synthetic fiber, because by addition of natural fiber in glass fiber can make the composite hybrid relatively cheaper and easier to use. Natural fiber we choose pineapple leaf fiber, and the synthetic fiber we choose glass fiber. By combination both half glass fiber reinforced epoxy hybrid composite will come out, so that the weakness properties of each other can be complemented. Pineapple leaf fiber is a wasted material, but it has high strength and modulus of elasticity. And also, it has low density and high cellulose. Meanwhile, glass fiber has high strength, superior impact resistant, adequate corrosion resistant, and suitable fracture toughness. Both have own problem. Glass fiber problem when we use unlimited usage can affect human or biodiversity system. And also glass fiber reinforced polymer difficult to disposal. Meanwhile, natural fiber problem is lower, the strength is lower because of less stiff and typically less brittle. Also, most problem is absorbing moisture. Mechanical properties of natural fiber are highly depends on shape, strength, and size affected by cultivation environment. Furthermore, the most important is there were limited findings in hybridization between PALF and bidirectional glass fiber. So, by combination, both we can come up with new material with environmental friendly but great mechanical properties. The objective for this study is to determine the effect hybridization on flexural properties of PALF glass fiber reinforced epoxy hybrid composite. The second, to characterize the fracture behavior of the hybrid composite using scanning electron microscopy. Here are the methodology. After we done the literature review, we come up with PALF physical properties analysis. At here, moisture, we measure the moisture content and density. Then, the preparation of short PALF, which is grinding process using this machine. And then we sieve the PALF using shiver machine, and then the output of short fiber is 15 millimeter and below. After that, we dry the PALF in oven at 80 degrees Celsius for 24 hours, then store in vacuum bag. After that, we alternate arrangement PALF with glass fiber at different fiber composition. Glass fiber cut accordingly, mold, then PALF spread evenly on glass fiber. Here are the table for weight fraction of composition. The acronym G at here is for glass fiber, 25 means for 25% of glass fiber, P means pineapple leaf fiber, and 5 means 5% of glass fiber. The percentage of glass fiber and PALF is total 30 and the balance 70 was epoxy. After we do the alternation arrangement, next we hand lay out the After the arrangement, we do the hand layout epoxy, then compression molding. We curing the plate with cold compression machine for 8 hours at least with 60 psi. Then after that, we cutting process using CNC machine. The dimension we use for flexural test is STMD 790 standard. And then after that, we do the flexural test as we can see in this picture to get the objective one. And after that, we do the morphology analysis SEM to get the objective 2. Here are the results after flexural test. Based on the table here, we can see that the highest flexural strength is G30 and the highest for hybrid composite was G25P5. Meanwhile, for flexural modulus, the highest one was G10P20. The sample can bear the highest force to bend was G, but it's more different. But the highest force to bend was G30, but it's just a small variance for 4% difference with G25P5 as the highest flexural strength glass fiber hybrid composite. Here are the results in bar chart for flexural strength and flexural modulus. The trend of bar chart was decline slope with increasing of PALF at the same time reducing of glass fiber was affected the strength of bending. There are 3 questions in our mind after we done the flexural test. First one, why higher strength is at G25P5 for hybrid composite? It is due to the weight fraction of glass fiber. As we know, glass fiber had high mechanical strength. Meanwhile, why highest modular was at 20% PALF, 10% glass fiber? It is because proportional limit in stress strain curve, this sample had higher stress cause high modulus. Other than that, natural fiber with high cellulose and low density will have high modulus comparable to glass fiber. Last one, why certain sample had no differences and had massive differences? The effect of conglomeration will weaken the adhesion between fillers and matrix, thus weakening the whole system. Here are the results for morphology analysis. As we can see, at 5% PALF, there was a lot of glass fiber fracture and had some void and fiber matrix cracking. Meanwhile, at 10% of PALF, there has glass fiber fracture, fiber pull out, and rough surface. 50% of PALF, there were glass fiber pull out, fiber matrix interface cracking, fiber breakage, termination with matrix breakage. At 20%, there was a lot of voids and fiber matrix interface cracking. But for the last one, 25%, you can see that there was a lot of cavity, PALF pull out, fiber matrix interface cracking, and glass fiber fracture. So we can say that PALF not well bound with epoxy matrix and had large amount of PALF pull out at 25% of PALF. Most of glass fiber had cohesive fracture and delamination due to the flexural stress. There were increasing of voids, uneven surface, breakage matrix, and cracks when increasing of PALF. The increase in PALF affected many defects in structural morphology after the experiment, resulting in decreased mechanical properties. The last one is conclusion. Conclusion for objective 1 is G30 provide high force for permanent deformation, but G10P20 had higher stresses at proportional limit, resulting in high material stiffness. Highest flexural strength of hybrid composite were less strength than G30, but only 10% and below differences. Can be concluded that the strength of hybrid composite decreases with the addition of natural fiber and reduction of glass fiber. Second objective, the interfacial adhesive between matrix and fiber were in good bonds when the natural fiber was reduced. It is because of less void, fiber and matrix breakage. The fracture surface also in smooth mode resulted in good mechanical properties. Sample with percentage increasing of natural fiber, the rough surface breakage of matrix and fiber void and debris was observed. It is because the natural fiber were poor in absorbing the epoxy matrix. And the last one, the increasing of PALF causing matrix of fiber breakage easily and dispersed on surface. Last word from me, although hybrid composite unable to beat synthetic fiber alone, but at least can reduce the use of synthetic fiber is also meaningful for environment. That's all from me. Thank you.